Hey everybody, here are some video solutions along with calculator instructions in the TI Inspire for the 5 steps to a 5, one variable data analysis FRQs that you were assigned. Let's go ahead and get started. Keep in mind as you watch this, you can pause at any time if you need to. All right, so question 1, Mickey Mantle played with the New York Yankees from 1951 through 1968. He had the following number of home runs for those years. Were any of these outliers? Explain. Well, anytime you're asked for outliers, in AP, we need to show the work. How do we figure out if there's outliers? And that formula for outliers is two of them, actually. We're going to do Q1, the first quartile, minus 1.5 times the IQR. And then we're also going to have to show Q3 plus 1.5 times the IQR. So that's my formula for outliers. I'll explain a little bit how we check as we find them. So in the calculator, you would go to, press the on key and new document. It's going to ask you to save, say no. And we're going to enter a list and spreadsheet. This is where we put our data. So I'd probably call this HR for home runs. I'm going to skip this line. We'll very rarely use that line, so we always skip that second row. And then I'm going to go ahead and enter these number of home runs. I'm going to carefully enter them into that first list. So I've already actually done that. So let me open that list up. So here it is. I typed all of Mickey Mantle's home runs in this first column, skipping that second line. So the reason I'm doing this, it's going to be an easy way to find Q1 and Q3. And then I can find the IQR by just subtracting Q1 and Q3. So to do that, we're going to add a page, so Control Doc. You see above Doc it says plus page, so Control Doc's going to add a page, and we're going to pick to add a calculator page. Now if you had 84s from before, you have one variable statistics. We also have one variable statistics in the Inspire. So I go to Menu, Option 6, Statistics, then Stat Calculations, and then there is my one variable statistics. This will calculate every possible statistic for that list that I entered on his home runs, even though we don't need it all, but we're going to need some of it. So I pick that, leave number of lists 1. My X list is the whatever I named your list. Make sure you name the list. If you don't see any there, you must have forgot to name the list. Leave everything else the way it is, and go down to OK. And here are my one variable statistics. And keep in mind, what I really care about is Q1 and Q3. Actually, the 5-number summary is pretty important to us. So I'm going to just cut these out real quick. I only care about that 5-number summary because I'm checking for outliers, but keep in mind on that same screen, one variable statistics, it does show your mean. It does show the standard deviation, so it has other useful things, but we really care about this 5-number summary right now. So let me go ahead and paste that into here. So here's what I care about. And let's go ahead and let's calculate these formulas now. So Q1 is 21. Minus 1.5 times the IQR. Now the IQR is 37 minus 21. That is 16. So interquartile range comes from Q3 minus Q1. And if I compute that in the calculator, I've already done this, you end up getting -3. So what this means is if there is an outlier, he's going to have some number in this data set of home runs that's smaller than -3. And if you look at my minimum's 13, so there's no outliers so far, but I gotta check the other side. So the other IQR formula is Q3, which is 37 plus 1.5 times that same IQR. And if I compute this, I get 61. And what that means is if there is a number in my data set greater than 61, that number will be an outlier. So if I look at my max, that's the highest value I have, it's 54, so there are no outliers here. So none of Mantle's home run years are outliers. Now, one more way you could check that, we did this first semester often, is you could have made a box plot. So let's just do that just to show how to make a box plot, box and whisker. So Control Doc would add another page. If you want to make any kind of graph, you pick Data and Statistics. I'm going to add my home runs at the bottom. And then Menu, Plot Type, and there's Box Plot. And when you make this graph, if there was an outlier, and first semester kids, you remember this, you would see a dot off one of these whiskers. So since there's no dot shown, that also confirms no outliers. But as far as the AP exam is concerned, they like to see this formula being used. All right, moving on to question 8. For the histogram picture below, what proportion of terms are less than 3.5? And it's actually, while we're looking at this histogram, it's rare that you're asked to make the picture. Usually you're asked to describe it or analyze it or to say something about a picture that's given. So here's a histogram that's given to us, and I want to know the proportion of terms less than 3.5. Well, 3.5 is right here. So I want to know what proportion are these bars in this histogram. How many values are in those red bars over the total number of values? So let's kind of count this up. So in the first one here, obviously you have 3. In the second bar, I have 6, it looks like. And then here I have 2. So in the red bars there are 11. And then let's total the rest of them up because I need to do proportion of all the values. So there's 11. Looks like here's 9 more. And here is, looks like 5 more. So that's a total of 25. So 11 out of 25 ends up being 0.44. So my answer here is just simply that 0.44 is the proportion of terms. I should write this out. 0.44 is the proportion of terms less than 3.5. All right, moving on to number 11. The following are the salaries in millions of dollars for members of the 2001-2002 Golden State Warriors. Which gives a better, quote, picture of these salaries, mean-based or median-based statistics. So let's talk about what it means to be mean-based or median-based. And you decide that question based on the shape of the distribution. So if the distribution is, I shouldn't say symmetric, but if it doesn't show strong skew or outliers, we're going to go with the mean. If it is strongly skewed or has outliers, then we'll use median-based statistics. So median-based statistics are things like median, measures of position like quartiles, IQR as a measure of spread. So if you remember from first semester, we use median and IQR when distributions are skewed or have outliers because those measures are resistant. Mean is not resistant to skew or outliers, so we only use mean-based statistics if our distribution is not strongly skewed or doesn't show outliers or is relatively symmetric. So let's go ahead and make a picture of this. You could make a dot plot by hand. I already typed these in a list and spreadsheet earlier. So here are my salaries, and if I want to add a dot plot, I press Control Doc to add a page, and we'll pick Data and Statistics. And I'm going to add whatever you named your list. If you don't see anything here, you forgot to name your list. And so if I look at dot plot of the data, I mean, there's no skew or outliers. It's almost a little bit uniform there, but there is no strong skew or no outliers. So what that means is we would go with mean-based statistics. So a dot plot of the data shows, oh my gosh, data shows no strong skew or outliers. So we would use mean-based statistics. On to question 12. Here they give us a frequency distribution table. This is the ages of 525 pennies from current change were recorded. 0 is the current year, 1 represents 1 year, etc. So all the way up to 11 years old. Describe the distribution of ages of pennies. And keep in mind, if ever we describe a distribution, that means we're describing shape, center, and spread. And we also mention outliers. So I went ahead and I just copy pasted from my answer key. It's really easy to make a picture of this. You could put these numbers in the middle. I just chose to put them on the outside. It makes my bars a little bit nicer. But this first bar represents 0 years old or current. This represents 1 year old pennies and so on. So I'm going to describe this distribution. So the first thing is shape. Obviously, this distribution is skewed to the right. So I would mention the distribution of ages of the pennies is skewed to the right. And then because it's skewed, when I go to mention center, I'm going to use the median. So to calculate the median here, I'm just going to think a little bit about, I have 525 values, and the median's halfway in there. So if I divide that by 2, I get about the 263rd value. So if I look at these bars, well, I have 163 in here, and if I add 87 to it, I'm almost to my 263, and I actually get to 263 in this bar here. So I'm going to describe the median. The median age is 2 years. And then let's go ahead and describe the spread. For spread, I'm going to calculate IQR, but I can just say the range here is good enough, even though it is skewed. And the pennies range is 0 to 11 years. With an IQR, which I calculate similarly to I do the median, right? The IQR is the median of the first two is Q1, and the median of the second two quartiles there is your Q3. So if I calculate those medians the same way I did here, if I go halfway in between, my median ends up being 0 to 4, or sorry, my quartile, my IQR is 4 minus 0, which is 4 years. And this covers everything I need to mention. It covers shape, center, and spread. And then something we often forget is context. So the fact that I mentioned the pennies and ages, that's me including context. All right, last question from this first set of FRQs. The mean of a set of 150 values is 35. I'll type it. So mean equals 35. The median is 33. Standard deviation is 6. And the IQR is 12. A new set is created by first subtracting 10 from every term and then multiplying by 5. So this new variable, I'm just going to call it y. Let's say this old variable was x. That's the original. This new variable y is going to come from subtracting 10 from every value and then multiplying by 5. So x minus 10 and then multiplying that by 5. So we have to think about what's going to happen to these values when I do that. Well, the minus 10 only affects the mean and median. It affects measures of center. It does not affect spread. And then I also have to remember multiplying affects everything. So I'm going to apply the minus 10 and the multiplying by 5 to the mean and median. But for standard deviation and IQR, because those are measures of spread, I'm only going to apply the times 5. So my new mean will come from, let me pause this and type this up. I'm running out of time on my video. So I just went ahead just because I have less than a minute left in this video. So again, the mean, I multiplied and I subtracted the old mean. Same thing with the median because subtracting and adding affects center. I also multiplied because multiplying affects center, and that's how I got my new mean and median. However, with measures of spread, the only thing that affects spread is multiplying or dividing. So here I multiplied both of those to get my new standard deviation and IQR.